Our final discussion in basic text processing is segmenting out sentences from running text. So how are we going to segment out sentences? Things that end in exclamation points or question marks, that's really great because those are relatively unambiguous cues that we've gotten to the end of a sentence. Periods, unfortunately, are quite ambiguous. If you think about it, a period can be a sentence boundary, but periods are also used for abbreviations like Inc. or Doctor. They're used for numbers like 0.02 or 4.3. So we can't assume that a period is the end of a sentence. So what we need to do to solve the period problem is build ourselves a classifier. We're going to build a binary classifier, looks at a period, and simply makes a binary yes-no decision. Am I at the end of a sentence? Am I not at the end of a sentence? And to make this classifier, we could use handwritten rules, we could use regular expressions, or we could build machine learning classifiers. The simplest kind of classifier for this is a decision tree. So here's a simple decision tree for deciding whether a word is an end of sentence or not. So a decision tree is a simple if-then procedure that asks a question and branches based on the answer to the question. So we say, am I in a piece of text that has a lot of blank lines after me? Well, if so, then I'm probably an end of sentence. What if there's no blank lines after me? Well, is my final punctuation a question mark or an exclamation point? If so, well, then I'm still probably end of sentence. Well, if not that, is my final punctuation a period? If it's not, well, I'm not an end of sentence. But if I am a period, well, then it depends. If I'm on some long list of abbreviations, like the word etc., then I'm probably not an end of sentence. I'm just a period marking an abbreviation, like doctor or etc. But if I'm not an abbreviation, then I'm an end of sentence. So here's a decision tree. And you can imagine arbitrarily sophisticated decision tree features that we could use. So one thing we can use is the case, or it's called the word shape of the word with a period. Am I an uppercase word? Am I a lowercase word? Am I all caps? So uppercase meaning the first letter is uppercase, lower meaning it's lowercase, cap meaning it's all caps. Am I a number? Any of these kind of word shape features can give us information. An all caps word is very likely to be an abbreviation. We can look at the word with the period. We can look at the word after the period. If the next word starts with a capital letter, then I'm likely to be the beginning, the period that ends a sentence, because the next word starts with a capital letter. And we can look at lots of numeric features. So we can look at, am I a long word or a short word? So abbreviations tend to be relatively short. Acronyms tend to be very short. And I can use very sophisticated features. So I can say, let's look at the word I'm looking at right now, take this word and ask, in a corpus that I've already know where the sentence boundaries are, how often is this word occur with a period at the end of a sentence? Is this the kind of word that ends a sentence? Is this a kind of word, for example, that tends to start a sentence? Is this the word that this phrase, for example, the word the after a period, very likely to be a capital THE after a period, very likely to start a sentence, the space in between. So this will have a high probability of being a start of a sentence. And we can use these kind of features, conditioned on each of the words, again, to help us in deciding what is or isn't a end of sentence period. Now, a decision tree is just an if, then, and else statement. So that's just the definition of what a decision tree is. The interesting research is choosing the features. So we've seen a number of features you might pick for this particular task. In general, the structure of the decision tree is often too hard to build by hand. In general, hand building of decision trees is possible only for very simple features or simple domains. You might build a simple decision tree with 6 or 7 rules like this for some simple tasks. But it's very hard to do for numeric features because you have to pick the threshold for each of the numeric features. I'm picking a probability as one of my features. I've got to have a question in the decision tree. Is this probability greater than some threshold theta or not? And I've got to set all those thetas. And so generally, we use machine learning that learns the structure of the tree and learns things like the threshold for each of the questions that we're asking. Nonetheless, the questions in a decision tree, we can think of them as the kind of features that could be exploited by any other kind of classifier, whether it's logistic regression or SVMs or neural nets, some of the classifiers we'll talk about later. So this intuition that we can build a classifier, we can derive features that are good predictors of whether a period is acting as an end of sentence or not. And then we can put these features into any kind of classifier, holds for whatever classifier we're going to be using.